Hi, my name's James Bowman. I showed a simple fourth CPU running on an FPGA last year, and at fourth day, and it was running Space Invaders. And I built a little VGA controller to do Space Invaders, which did sprites and colors and that sort of thing. And it was so much fun, I decided to press on with it and turn it into a 8-bit style, like an old Nintendo video controller for doing old-style video games, which is what I used to do for a living. And this is the result. I turned it into an actual product as an Arduino plugin. And this is... let me just reduce its volume. So it does... fixed it. This is what eventually got manufactured. There's a big FPGA in the middle, and not much else. A bit of RAM, a bit of ROM to boot it, and it slots on top of the Arduino. So Arduino, if anybody who hasn't heard of the Arduino, good. It's an Arduino shield, so it plugs down onto the Arduino and then gives you a VGA, analog output, and an audio output, and it does all of the graphics and audio processing to do video game type stuff. This is another shot from the manufacturer, and as you can see, it sort of does simple 8-bit style graphics. You've got a background layer and a sprite layer, and it has 9-bit color, so that's 512 colors, and this is all happening on this FPGA, which is booted from this ROM here. FPGA, I put all of the graphics functions in the background, the foreground, and then the audio stuff. And there's quite a bit of room left over. So I put in a coprocessor block on there. Of course, it was the same old one I used last year, the J1. And that easily fit in there. But there wasn't enough room to give it very much RAM. So it only has 128 instructions available. So everything that runs on the coprocessor on this chip has to fit in 128 instructions. So that's enough to do one thing. Usually, you have to choose what you're going to do with it. So the overall system you get is an Arduino, of course. You have this guy plugging in on top, and you have the Gameduino running with a coprocessor in it doing some independent thing. And that's what I'm going to be showing today. There's the old J1 slide. These slides are actually running on the Gameduino down here, so that's why it all looks a bit low res. So here's a simple program that runs on the coprocessor. Because we've only got 128 instructions, that's 256 bytes. So as far as the Arduino is concerned, it just looks like another patch of memory. The Arduino writes the program into 256 byte instruction RAM, and here is a 10 instruction program. Everything runs in this begin again loop. It accesses the hardware random number counter, stores it into a memory pointer, goes down 1 in memory. I don't have a 1+, that seemed excessive. So there's only a 1-, and then it masks it with 1FF. So it's continuously filling the range from 0 through 1FFF with random numbers. And voila, there's the result. So you can see it's just running like crazy. It's always on, and the Arduino isn't doing anything. It's just sitting there, and the coprocessor is doing some simple graphical task, in this case, generating random numbers and putting them into video memory. And the sprite layer, of course, is still running. That's why the text, if you look closely, is still visible on top of this background snow effect. Slightly longer program. So there's a bunch. It was fairly easy to add a bunch of dedicated registers onto the CPU. That seemed to come super cheap in the FPGA, that it could access all sorts of aspects of the machine. Shared memory architecture. So the Arduino video memory, and the coprocessor looks at video memory, and there's a little bit of contention resolving logic to make it so that they can both do it at the same time. So they're actually both accessing this memory in this 32K of video memory in a symmetric way, so they're sharing it. So here it's another begin-end loop. It looks at the Y line, which is the raster line, which goes down the screen from 0 to 299. Offsets it by this shared memory variable, this com plus 0, which I'll get to in a minute. Clamps it to the range 0 to 63. And there's the familiar fourth idiom for looking at up in an array starting at this memory address. Accesses that and then writes it into the background color register. So we take the Y line, offset it, clamp it into a range, look it up in an array, and write it into background color. And here it is running. So this zone here at the 64 colors, which the Arduino has loaded into this piece of memory, and by varying this value in com plus 0, the one there, it can slide it up and down the screen. So as far as the Arduino, it kind of starts to look a little bit like a piece of dedicated hardware. The Arduino has loaded this program, and at this point, all it has to do is update what's in com plus 0 and to get an immediate visual effect. There's no delay at all because this guy's continuously running. And there's no real complicated API because it's just they're both reading out of this same bit of memory. So, for example, if it wants to change the colors to a horrible collection of random ones, there it's just filled 3E80 with some random numbers, and you get that horrible mess. That was pretty good, and it was kind of striking how much you can do in just a couple of dozen instructions. So I tried to do something more ambitious, which is emulate the, who knows what this is? So it was very popular in Britain. It's an 8-bit computer from the early 80s. I'd had a dedicated video chip, which was a bit odd. It had a video format which was 6K of RAM, and it was actually kind of odd to use because it was a 1-bit display, but it had little tile color indicators. So you could only have 2 colors in any 8x8 block. So a kind of odd video system, and it's kind of hard to emulate. And I wanted to emulate it on the Gameduino. It's very different from any other modern video system. So what's going on here is that the coprocessor is working like crazy, doing on-the-fly conversion of the video. So there's a big block of Arduino, of Gameduino memory of 6K, which is the original video memory of this old machine. And then as the raster is going down the screen, it's doing that conversion, reformatting the data for the Gameduino's output. So as every pixel line goes by, it's doing a double buffered conversion, switching doing the video conversion from old format to its native format. So as far as the Arduino is concerned, there's 6K of memory, which looks like a ZX Spectrum's video system. It doesn't have to do anything at all. It just writes to it, and it gets the, exactly the same output. So again, it's a bit like that single register write. The Arduino doesn't have to do any work. It just looks like a piece of memory, and on the video side, it's doing all sorts of conversions to give some visual output continuously. So as you load it, these aren't screenshots I'm loading. They're actually memory shots of the original memory dumps from these emulated games. So it goes on. And this is, I got close to running out of room there with my 100 instructions. So it's about as complicated as you can get. And the last thing is a little bit of assistance that we can give. So in all of the other examples, the Arduino has been basically idle. And in this example, it's working together with the coprocessor. It's a genuine coprocessing arrangement. The Arduino is pulling images off the SD card here, and it's writing them into Gameduino RAM. And then the coprocessor is helping a bit to do a synchronized blit. It's waiting until it has reached a certain point on the screen, and then copying the video so that you get a tear-free video transition. And Play it, and there we go.
You Rickrolled us.
So there we go. That's streaming about 200K a second into video memory, and then the coprocessor, the fourth, is pulling the graphics and then synchronized doing a blitz, so it doesn't have to do any double buffering. That's all. You. So yes. Yeah. So that's that in 9 minutes.
Questions, comments? All right.
All right.
Well, Gary.